The first step to model a building in Revit is setting up the levels. Revit levels represent the floor levels in a building, and all the elements we model will be located on those levels. Start by creating a new project using the architectural template. The level command is located on the right-hand side of the architecture ribbon. We can see, draw, and modify the levels only in a section or elevation view. This is why it is grayed out here, as we are in a floor plan view. So let's go to the south elevation and then pick the level command. Then, having the line tool selected, click on the drawing area to place the level symbol. The cursor will change, indicating that you are in the process of placing a level. Move your mouse cursor to the right and do another click to finish creating the level. After making a new level, Revit establishes a new plan in the project browser associated with that new level. But if for any reason it doesn't happen, don't worry. Go to the View tab, select Plan Views, then Floor Plan. In the pop-up window, select the recently established levels and click OK. Now, check the project browser to see the views associated with those levels. If we delete or rename any level, Revit asks if we also want to delete or rename their plan views. Let's delete levels 1 and 2 and select OK. Now, there is no view associated with level 1 and 2 in the project browser. It should be noted that deleting views will not cause the deletion of their associated levels. Each level is comprised of different parts: level name, level elevation, level head, and level line. To change a level's name and elevation, select them and change them either in the Properties palette or by clicking over their value inside the drawing area. I want to rename this level the base level and leave its elevation at 0 to act as the project's sea level. Revit is asking if I want to rename the view accordingly. By choosing yes, the level's view name will update in the project browser. If you're finding this video helpful, check out revitgamers.com. Our courses go beyond the basics, bringing Revit to life with hundreds of dynamic visuals and animations that make complex concepts feel easy. This unique training approach is designed to speed up your learning and make BEAM adoption smoother than ever. Every day, more students and companies are joining Revit Gamers Club to elevate their Revit skills. Don't miss out. Head to revitgamers.com and see how Revit training can be fun, visual, and incredibly effective. Now, that's the time to define the other levels. Let's assume that this project's ground level is 33 meters above sea level. So let's select the Levels tool and draw a second level. But because I already have a level created, I can choose that level and then click on Create Similar in the Modify ribbon. The Create Similar command is the faster way of creating new objects similar to the existing objects. The whole process is to select the currently modeled object and then select Create Similar or use the shortcut CS. Now, let's create another level. Move your mouse cursor all the way to the left, close to the current level head, so you can see this dashed blue line appear, and then click on an empty space above it. Now move the mouse cursor all the way to the right, close to the level's tail, to see that dashed blue line again, and then click. This way, we have locked the extent of the levels, and every time we hover over the end of one of them and drag it to the left or right, the other one will also move. If you want to break their connection, have one of them selected, click over this padlock, and then see what happens. Now let's use what we've learned so far to add some more levels to the project quickly. On each side of a level, there is a checkbox using which we can toggle between the level head and the level tail. In case two levels are close to each other and their texts overlap, you can select one of them and click over this break symbol to add an elbow to the level. Now, using these control points, we can adjust the location of the level heads. Please note that this change applies only to this view, and you need to repeat it in any other view if necessary. Levels can be assumed to be the most important elements in a project, since all the objects in a project must be associated with a level. Be aware that making changes to the level elevation or deleting it will significantly impact all its associated objects. Deleting a level will also cause all its associated objects and views to be deleted. But before that, we will get a notification confirming whether we are sure to delete the level. Please note that deleting all the associated views of a level will not cause the level to be deleted. Now that we have learned about levels, let's start adding some objects to the project. But before that, I have to clarify how each architectural element is associated with a specific level. In each element's instance properties, there is a level parameter to choose their associated level, and for some of them, an offset parameter to set the distance of that element to the level. By setting these two parameters, we can define at which distance to which level we want the object to be located. Consider this floor. It is located exactly on level 0. Looking at its instance properties, we can find two parameters named level and height offset from level. Changing the level parameter to level 1 will move it up for one level. Changing the offset value to 2000 moves the floor 2000 millimeters upward. Changing this parameter to minus 1000 will cause the floor to be located 1000 millimeters below the level 1. For doors and windows, these two parameters are level and sill height. Changing the sill height will move them up or down. For roofs, they are base level and base offset from level. As mentioned, they might be slightly different in name, but do the same job. But for some other elements, like walls, columns, stairs, and ramps, we need to specify the level and offset value, one for their base and one for their top. For instance, to determine a wall's height, we need to adjust 4 parameters. Base constraint to pick the base level, base offset to adjust the base distance to that level, and top constraint and top offset to determine the elevation of the top of the wall.